Elegant in design, precise in function, built with one purpose: to end lives. The machinery of execution stole from and inspired many of the world's greatest inventions. It mechanized torment and terror. Coming up next, the engineering behind the machines of malice. The world's first execution machinery was simple and remarkably effective. This technology harnessed three very basic forces of nature: fire, force, and gravity. But just how did these ancient death devices work? The only way to answer this question is to bring these deadly machines back to life.
Execution, torture, and technology share a similar road in human history.
There is an untold story behind many of the basic inventions that have improved our society.
Individuals that have suffered execution and torture have not only changed the societies around them, but are really demarcations of points when history can take a turn in a new direction.
The year 570 BC. Greek city-states experience incredible growth under the iron fist of local strongmen called tyranni. These tyrants advance their cities with new technology, but they're also known for their cruelty. Here on the island of Sicily, one of history's first machines of malice goes on record: the brazen bull. The concept of the bronze bull is simple, but the execution is downright diabolical. This deadly device doubles as a musical instrument.
What's interesting about this is that it follows along a certain kind of fascination people have with technology in making an inanimate object seem animate.
To the ancient Greeks, bulls were a symbol of absolute power. This is why bulls like the Minotaur are so prevalent in mythology. Some early Greeks believed in a bull-headed god called Moloch, who demanded human sacrifice. The brazen bull could be a tribute to earlier bull worship and human sacrifice. Here's how it works. A hinged trap door opens up the bull's back. This reveals a hollow chamber where victims are locked inside. Flames from a fire pit beneath then lick the belly of the beast.
Instinctually, if you're locked into any sort of dark space and you're trapped, you know you're not going to get out. Panic is going to set in, you're going to have an acute stress response, tachycardia, your heart rate is going to increase, you're going to have increased respiratory response, breathe much faster. Essentially, you're going to start panicking, especially when that bull starts heating up.
So basically, the brazen bull is an oven built to cook humans. But then the device gets really twisted. Inside the head is a system of brass tubing that converts the high-frequency screams of a burning victim into the low-frequency bellow of an infuriated bull. Nobody knows the exact configuration of the tubing inside the original brazen bull, but historical writings describe an eerie musical quality. This death machine may very well have been one of the first attempts to create a sophisticated brass-type musical instrument. But is it technically possible to convert the screams of the burning victims into the sound of a bull?
The idea of putting a length of tubing or coiled up tubing inside the bronze bull is not at all far-fetched. The pitch level and the harmonics are about the tone a trombone would make.
The screams of the bull's victims can't be heard because the metal acts as a sound barrier. Sound waves can't travel through material as dense as metal. However, if the fire superheats the air inside the brazen bull, a victim might struggle to reach the tube built inside the bull's head. The victim could siphon fresh air out of the tube and then exhale while screaming.
I would imagine inside the bronze bull, if there was only one spot for him to breathe in as he's screaming back out again, it must have sounded something like this.
Ancient texts describe how the tyrant Phalaris wanted to test the bull's musical properties. So he commanded the artist who built the bull to climb inside and scream like someone being burned. But in a moment of fiendish trickery, the tyrant locked the trapdoor and lit the fire beneath. The machine worked as promised. The artist was the brazen bull's first victim. Haunting acoustics aside, the brazen bull's metallurgical properties make it a mechanical horror. The ancient Greeks were skilled metal workers. They could certainly craft a realistic piece of this size.
Bronze is a relatively low temperature metal. It would melt at about 1800 degrees. It's an alloy of copper and tin. For something close to 1,000 pounds, which is what a full-scale bull would weigh, they probably would have made it out of sheet metal like this, and this is sheet bronze right here. If the fire maybe reached 5 to 1,000 degrees, it's not going to melt the bronze, but it would soften it.
The brazen bull is basically going to be conduction heat, which is ultimately what's going to kill the condemned. When you have that flame that's going to be underneath, it will actually heat out in a cylindrical pattern depending on the mass all the way through the entire thing. So depending on how big the flame is, this whole thing will uniformly heat.
To understand just how quickly heat transfers through bronze and into flesh, blacksmith Tony Swatton has devised a simple experiment. Build a bowl from bronze and sear chicken meat.
This is relatively light metal, but anyone inside of this would not be able to get out of it. Bronze work hardens to almost the degree of the steel once you hammer it. So now we're ready to cook.
The chicken meat simulates human flesh. It will help visualize how quickly heat transfers into a person when in direct contact with bronze.
You're probably going to be getting at least 800 degrees on the inside of this. You can see the heat developing here. This will get to a red heat. And see how it's getting red right there? So that area is red from the contact with the flame underneath it. And the chicken underneath here is still burning. So you can see it's just like cooking in a regular frying pan. Now if I'm doing direct flame, I mean that chicken's on fire. The heat and smoke and fumes coming off of here would be suffocating you on the inside. The pain would be horrible. And you'd be burning to death.
When the person is placed inside this brazen bull, it's just like cooking a turkey in your oven. You burn the outside of the skin and you slowly dehydrate the inside, and if you leave them in there long enough, it will eventually become very tough and very dry. The heat itself would slowly cook you from the inside out.
The extreme heat engulfing the victim would make for a short musical performance before heat exhaustion knocked him out. One can only speculate how quickly the brazen bull would then finish him off. Based on the extreme dehydration trauma, the survival window is under 10 minutes. For 16 years, the tyrant condemned anyone who challenged his power to cook inside the brazen bull.
Tradition, of course, has it that Phalaris enjoyed this device so much that he would use it during banquets, inviting people over, listening to the bull roar, and also masking the scent of the roasting flesh by adding aromatic herbs so there was more of an effective incense in the air than of burning human flesh.
This is not something you just did and walked away from. This was a source of entertainment. I don't know what kind of person would think of that. It's absolutely cruel, it's absolutely sadistic, and completely inhumane.
Ancient texts state the cruel brazen bull was tossed into the ocean immediately after Phalaris was tossed from his throne in 554 BC. But the technology of the brazen bull persists today. The sound of this machine is a one-note terror. But today's brass instruments can play an entire range of musical notes. When humankind's greatest discoveries are listed, the ability to control fire undoubtedly rises to the top. As much as fire has improved and advanced civilizations, it has also facilitated countless executions. And there is no fire-fueled machine of malice quite as horrifying as the Wicker Man. The year 500 BC. While ancient Greece flourishes and the Persian Empire awakens, a seemingly mythical machine of malice strikes fear across the area now called Western Europe. Every May 1st, the Celtic tribes celebrate the coming of summer. They pay homage to the time of year when livestock herds are brought to grazing pastures. Even today, there are May Day and Beltane festivals in Europe, celebrating the coming of summer, including this actual Wicker Man burn in Scotland. Only here, no one is put to death. It's none other than Julius Caesar himself who first documents in 58 BC this shocking pagan execution ritual.
Caesar's reference to this is the sole reference that we have, not only to the event, but also to the fact that it incorporated a sacrificial element.
The ancient Celts tie up people and livestock inside each effigy. Julius Caesar describes the Wicker Man's victims as thieves and prisoners of war.
This event is not only just a sacrifice, it's also a kind of spectacle and public show. Just like at 4th of July, you wouldn't want the fireworks to take only 5 minutes. You probably wouldn't want the burning of the Wicker Man to collapse in a few minutes.
No one knows exactly how the ancient Celts built the Wicker Man. But the design needed to be strong enough to support the weight of human and livestock victims. The goal of the Wicker Man burn is to please both the Celtic deities and the festival participants. The flames leaping into the night sky serve to mesmerize the spectators. To achieve this effect, the Celts wrap the structure in highly flammable brush and thatch. But the destructive power of the fire could quickly collapse the Wicker Man if there are no central support columns.
They would have cut down trees and used them as our support in our columns. That actually is an amazingly strong shape to use, and it's readily available for them. Large structures, we pretty much always try to use cylinder. It's just now, with modern times, we're going to use a square beam. It's easier to attach things to, it's easier to build, it's easier to work with than an actual cylinder. There are concrete parking garages today. You're going to see either a round cylinder or you're going to see a square beam going through to handle all the compression loads. You put a load on top of the cylinder, you're going to have an equal and opposite force acting through the ground back up to your point. So your area of your beam is what's holding that load.
So the total thickness of each leg determines how much weight the Wicker Man can support. Larger diameter legs also keep the structure from collapsing into a fiery heap when engulfed in flame. As a rule, the thicker the columns holding up the torso, the longer the figure remains upright. The ancient Celts did not have carpentry techniques advanced enough to build square columns, so they would have secured the tree limbs with twine lashings to create cylindrical columns. Even though this modern replica uses nails, it relies on the same basic engineering principles to support weight high off the ground.
We are rushing, as you can see, to get this done and built before sunset, so we could actually imitate what they did in the ancient times and burn at night. We're using thatch to cover the whole thing. That is what we call it would be a kindling. Very low flash point, it could start relatively easily, and then that actually will transfer the flame to the wood.
But for those unfortunate to be lashed inside, the fast-moving fire means an agonizing death. How quickly that fire moves and how long it takes to destroy the structure is subject to debate.
Most likely with the heat, it's actually probably not a quick death, in that you suffer a lot of pain with the burns that you get, and you also get smoke inhalation injuries. Your trachea will swell. In essence, what the fire actually is doing is just drying you out from the inside out. From a medical standpoint, this has to be one of the most painful ways to be put to death.
Fire is going to start eating the wood from the outside in. And whenever you make a structural column or a beam, the outside is actually the strongest part. That's what's holding all the load. The inside is what's called your neutral access. That's the reason why you can drill a hole in a beam and you don't degrade its actual structural integrity as long as you're in the center of that beam. Right, and actually you can see Rudy up there, and we're actually supporting him right now. And there's not a lot of wood there.
Unlike the structures built for modern-day Wicker Man festivals, this 22-foot-tall replica has room for 3 humanoid forms. Now it's a question of how long it will take for the fire to overwhelm the Wicker Man. instantly races up the highly flammable thatch skin. The inferno overtakes the victims. It burns completely out of control. Now, with the fuel of the kindling burned up, the fire attacks the structure.
We're standing so far back right now, and it is incredibly hot. Right now, the fire is working its way into the center of the wood, and see how it's starting to get notched out? The outside of it getting C-notched. That's significantly weakening the structure as we speak. If you put a really heavy load on that right now, it would definitely collapse. There it goes. So ultimately right now we have gravity, and the weight of the arm created a moment which actually lifted it all the way to the opposite side. Instead of collapsing in the side that all the beams went down, the weight of that arm picked it up and moved it the other way.
Based upon this modern-day demonstration, the ancient Celtic wicker man could have burned for several hours. Although the wicker man is a simple machine, it demonstrates structural techniques that can be found in many heavy construction projects. Modern steel and concrete columns can support the massive loads of roads and bridges using the same engineering principles as the wicker man. After mastering fire and heat-powered death machines, ancient executioners found inspiration in humankind's oldest and most important invention, the wheel. The simple design and physics of the great wheel make it a versatile death tool. No one knows its exact date of origin, but it most likely rolled onto the scene during the early part of the Roman Empire, executing early Christians and traders alike.
The wheel not only transformed transportation, it revolutionized execution as well. And it just goes to show that oftentimes technology, execution, and torture travel along the same road.
The design of the great wheel is simple. Two standard chariot wheels are attached by wooden planks to create a cylinder. The round design of the cylinder makes it easy for the great wheel to roll downhill, bounce through rocky terrain, and gain speed.
We did some simple calculations. Going down a hill with gravity, we can actually create a force equal to a 120-mile-an-hour car crash. The way that works is as this wheel is spinning, it creates a motion. When the motion hits something that is not moving, like the ground, it creates an impact force. Every rotation would be like being in a car accident over and over again. And not only that, is the more you come down the hill, because gravity is increasing your speed, the crashes get worse and worse and worse.
For the wheel to survive such a violent downhill roll, there are several engineering challenges. The wheel needs to be light enough to carry up the hill, heavy enough to gain momentum, and strong enough to withstand impacts with rocks.
As this is spinning and gets faster and faster, the energy has to go somewhere. And in this device, it's going to go through your body when you hit the ground.
The engineers choose a 185-pound anthropomorphic dummy to simulate the execution.
It's just a simple thing of mass. We have put a mass to a certain height, we're going to have potential energy. We drop that mass, it turns it into kinetic energy. Gravity is going to act upon it and pull it down the hill.
G-loading stickers affixed to the dummy will indicate where the wheel causes the greatest impact injuries. Each sticker is designed to trip only after experiencing a specific amount of instant deceleration. The impact causes the vial of white fluid to turn red.
We have our red ones, which are 50 Gs, which would be a broken bone. So we're going to put that in areas where you would possibly have a broken bone.
A 50 G impact force is equal to a really hard tackle in a professional football game.
We have orange stickers, which are 75 Gs, which would be internal trauma and internal bleeding. And we're going to put those on the actual torso.
When Princess Diana's car crashed in Paris, a 75 G impact severed her pulmonary artery.
An actual blow to the head at 100 Gs is an instantaneous death. So we're going to go ahead and put a green sticker for 100 Gs right on that head.
Falling off a bicycle and hitting your head can generate a 100 G impact.
Now I'm going to go ahead and label him all the way up.
You can see he's in an extremely vulnerable position. I mean, generally, your usual protective stance would be to curl up in a ball in the fetal position to protect all of your vital organs. We've got the exact opposite here. So I think it's really maybe 3 or 4 revolutions before you're just completely out. You know, we've got these G-force stickers on his head, which is great because obviously a severe impact to any part of his head is going to be fatal. However, when you're looking at him, his face is really what's going to hit first. So I think we need a G-force sticker directly on his face, especially because if you think about it, you've got the nose right here, and whereas, you know, in a bar fight, you're getting punched in the nose, broken nose, not necessarily a big deal. In this type of situation, you've got the ground coming up at you this way. That could be enough force to actually hit the nose, send bone shards up into the brain, and kill you that way.
Well, we're tying our dummy onto the wheel here, face up. In a minute here, we're gonna let him go. See how he does. I'm locked off down here, Rudy.
3, 2, 1. Actually, you know what it's doing? It's throwing the head forward into the ground every single time. That looked like it hurt.
Yeah, and I think that hurt quite a bit, actually.
Quite a bit.
Well, let's go take a look.
Well, I would say I was very surprised by how slow it actually did go down the hill. The wobbleness of the weight on the outside actually slowed down the momentum, but at the same time, it seems to me like it created a whip motion, which would snap the head back and forth. As it would roll, the velocity of the circle going down would smack his head straight into the ground. And with the movement of his head being so flimsy, I could definitely see him breaking his neck.
The repeated impacts trigger both G-loading stickers attached to the dummy's head. This means the great wheel delivers 100 G death blows. The descent also triggers both 75 G stickers affixed to the chest. This means deadly organ-rupturing injuries. Based on these results, death would have come quickly, possibly even immediately, for anyone condemned to the great wheel.
Not only do you have the force of the head actually hitting the ground, but when it comes back up, you are getting that whiplash motion.
Yes.
And it's a combination of force as well as rotation of the head that's really going to do you in a lot of times. Even without the force to the nose, I think the whiplash could have snapped his neck before he really died of any sort of internal injuries or anything.
The great wheel causes near instant death. This means the spectacle of strapping a criminal to this device sent a message to spectators. Roman law was highly punitive, and this is why the wheel evolved into new versions designed for more torturous deaths. There are accounts of narrow wheels powered by hand cranks. Executioners push the handle to rotate the wheel and repeatedly roll the accused over fire or a bed of spikes.
The great wheel is in part a testament to the imagination of humanity in being able to figure out what a common everyday object would be able to do when applied in a cruel and inhumane way.
As ancient Greek city-states developed refined metal and woodworking techniques, they gained a basic understanding of how force and pressure could mechanize execution. The year 200 BC, in the southern Greek city of Sparta, a deadly device springs up with the ability to mechanically impale its victims. They call it the Apega of Nabis.
Now, the Apega follows in a long line of kind of android-like figures that go all the way back to Homer. And in fact, Aristotle and Archimedes both write about articulated puppets that could be moved in a lifelike animation. But the Apega was no toy.
Some scholars theorize the Apega might be a story used as propaganda to further the ambitions of the Spartan tyrant Nabis.
The way that this apparently took place was when Nabis would invite prospective donors over to the palace and give them a banquet, and with wine and persuasion, attempt to wrest more money out of them for his projects and for the defense of the Spartan state. If this didn't work, he would say something like, well, I guess I'm not going to be able to persuade you, but perhaps my Apega will have more luck. And so if he wasn't persuaded at that point, it would probably be his last meal.
Under the robe of the Apega is a highly technical machine. To work properly, the Apega needs a realistically painted face to fool the victim. The machine is powered by a single spring under tension. Along the hinged arms are sharp bronze spikes ready to impale.
The basic premise is having the stored energy is you got to put energy into the system and then have the system be able to retain that energy until I release a quick disconnect or something to activate energy that comes out of the spring.
A trigger plate built into the Apega's chest releases the spring and seals the doom of the victim.
The amount of force that you would have to be able to hold, store, and apply to one person would be a very difficult thing to do at that time.
This story assumes that the Apega's victims are either drunk enough to think the device is human, or they are sent by force into her deadly embrace.
You can see on this particular spike that I have here is very sharp, and it wouldn't really take much to penetrate my skin. The pain associated with multiple stab wounds into the upper extremities would be intense. Vital organs, including the lung and the heart, would be immediately at risk and could potentially be life-threatening.
Here's a type of handgun defeating body armor of a lower level. And you can see by just putting the spike here and pushing, I can get a decent amount of energy. What we now have is a drop mask with a spike on, similar to the Apega. And I'm using the same amount of energy. However, it's all going to be focused right there. 3, 2, 1. But what you can see here is you have good penetration. You can still see that it took a bit of energy because it still dented the foam backing material. But there's clear penetration, probably about 2 inches on this. But it does show you how well an implement with a very small point can penetrate without needing the speed that a projectile has coming out of a hand. The Apega would have been very effective because once the skin was pierced, till the arm came to a stop, it would have continued its penetration until that point.
From a modern perspective, spring-loaded spikes seem simple enough to design, but in reality, these mechanisms require tremendous engineering and technical precision to work properly. The Apega of Nabis operates like the giant spring-loaded clamp of a bear trap.
You have a simple clamp here. Here's your lever arm. Here's your pivot point. Here's what you're clamping. When you load it, they would have a trip pin that would be sitting in the front. And as soon as somebody came in to hug her, they would trip it, it's gonna smash the person. If you try to do that in reverse and try to lift up the smaller part, it's really, really hard to do. So your mechanical advantage is in the back part of the arms.
To set a spring large enough to clamp the arms of the Apega requires a great deal of energy. The engineers solved this problem by building really long lever arms to tension the spring.
They would have had to use very primitive materials, and just the lever arm mechanism of squeezing and actually spiking somebody is a very difficult problem. So if you use an actual loop of a piece of wood like a bow and arrow, you can put it in between 2 lever arms that come out and actually lock it into a spring.
To trick a victim into believing the Apega is real means concealing the extra long lever arms built into its back. So the Apega needs to be placed up against a wall with the spring mechanism hidden on the other side.
I think it's science fiction of the times. There'd be so many mechanical devices behind this and around this to make it work properly. It'd be hard to fool somebody. I think it's a little bit unrealistic for somebody to be able to create a clamping mechanism like this to lock somebody in those spikes at this time period. The spring would have to be able to hold an immense amount of weight. The person that would get trapped in there would be fighting it, so he would try to push those arms out. And unless the spring was big enough to hold all that energy in, when it was in its shut position, I don't think it would have worked.
Although the Opega seems beyond imagination, the Greeks were awfully ingenious people, and the tyrants were particularly ingenious at putting technology to work in very cruel ways.
Our next machine of malice looks remarkably similar to one of the world's most powerful religious symbols, the cross. Christianity's cross evolved from the Roman crucifix, an execution machine reserved for foreigners and common criminals. Today in the Philippines, a Christian sect has brought back the ancient Roman techniques of crucifixion. They are attempting to prove their religious devotion during Good Friday worship. These modern-day crucifixions are closely monitored to minimize pain and discomfort. But the fact is, these crucifixions are excruciating. This participant is removed after only 5 minutes on the cross. The pain is so intense for this worshiper, he's brought down in less than a minute. These modern-day crucifix practitioners can't help but feel the unrelenting and deadly pull of gravity. But what they might not realize is that this is not an accurate portrayal of the Roman crucifix machine.
One of the things that knit together the Roman world was a kind of consistency of urbanization. You could go to any city, practically, and know what to find, baths, places to stay, but you also knew, as you passed into the city, that there was a place of crucifixion. And as visitors, whether they were Roman citizens or the people that they were supposed to control, they would pass by these areas that demonstrated Rome's power and might.
Crucifixion is part of Roman propaganda. Don't rebel against Rome. These are the consequences. And crucifixion was reserved really only for those criminals that threatened the Roman order. Anybody that was a threat or even perceived as a threat would be crucified. And that's what they used to keep the provinces and the people in line. So really, the longer you have someone on the cross, the more effective it is from the Roman perspective.
Well, we've got a 12-foot high crucifix, and we're going to try to dig down 3 feet. 3 feet, I think, will give us enough stability once we get it in there.
So when thinking of the crucifix, you've got a very simple device harnessing a very simple power, the power of gravity, to come up with one of the most inhumane ways to die ever. You've got the pain, the humiliation, the possible exposure, just about everything you can die from.
Jeremy, we're going to put this in our hole. Just hand it. Okay, and then let's turn it so it faces right about there. We're positioning it this way because the condemned is facing the morning sun. He's exposed to the elements all day long.
The Roman crucifix consists of a vertical wooden pole 9 to 12 feet tall. A full 1/3 of this pole serves to permanently lock the device into the ground. Next, a shorter 6-foot horizontal beam, called the patibulum, attaches on top via a mortise and tenon design.
When they would put a person on it, they probably would put the person evenly distributed on both sides so that it's a balanced weight going through your center beam into the ground. As long as that beam's also center with them, you have a great amount of structure right there. Basically, the vertical post is ultimately taking all the weight of not only the person on the top, but the weight of the beam that's going across the top.
The crucifix structure contains no moving parts until the victim is attached to it. Then, gravity does all the work as the victim slowly and painfully melds with a machine.
His arms, because they're at an angle, are going to be holding probably twice as amount of load as they would in a vertical position due to the angle of the actual T that the person is positioned into. It's like a gymnastics. If you're doing the rings, you can hang on those rings all day long, but then when you try to do the iron cross, it's almost impossible to hold yourself.
At the crucifixion site, rope secures the victim's outstretched arms to the horizontal beam. Roman soldiers drive 9-inch soft iron metal spikes through olive wood washers into the hands or wrists to permanently bond man and machine.
Most of the Roman crosses would have been what's called a tau shape, that is to say a capital T, and not what we call the Latin T, which is what we're more or less accustomed to, especially in the West, when we think about the cross. The reason for that is if you're trying to hoist up a victim onto the cross, if you've already nailed them on the ground to the patibulum, that is to say to the crossbeam, all you have to do is hoist them up, slip it in at the top, and you're done.
This means the main vertical beam is left in the ground for multiple crucifixions. Just the top horizontal crossbeam leaves the crucifixion site. This makes the crucifix an incredibly economical execution machine. Scientists differ on what parts of the arm can sustain being spiked. Recent studies indicate that the gap between the ulna and the radius bones in the wrist is the most effective way to secure a crucifix victim.
Now, the big problem if you do it here is the possibility you can hit an artery and then they die really too quick. So what a lot of scholars think is that the hand would have been tied with a rope, and then to maximize the pain, you would go through the hand. But of course, if you don't have the ropes and you just go through the hand, there is the possibility that someone could sort of rip their hand from the nail and get down off the cross.
Perhaps the cruelest part of the crucifixion is the insertion of iron spikes through the feet. It's not the immense pain inflicted from the wounds that's so insidious, but ironically, it's the temporary relief they provide the accused.
So one of the popular theories from dying on the crucifix is that you actually die of asphyxiation, that when you're hanging there, your diaphragm is so compressed that while you can inhale, you can't exhale.
So a crucifix victim instinctively tries to lift his lungs to exhale by pushing up against the iron nails in his feet. This is an attempt to release the diaphragm from the grip of gravity. But the act of applying pressure against the spikes reactivates the damaged nerves of the feet and hands in an explosion of pain.
Altogether, you're dealing with the pain both from your hands and quite possibly your feet. You're dealing with probably at least a little difficulty breathing, not to mention the exposure from the elements, dehydration, hunger, wild animals, whatever you have coming at you.
Either way, the force of gravity ushers in a most painful death, as it constantly exploits the weaknesses of the human body. For a great portion of the modern world, what started out as an infernal device of torment now serves as a humble symbol of religious piety. The crucifix is a death machine, transformed into an icon for one of the most popular religions on earth. As the Roman Empire attained the pinnacle of its power, and 1/4 of the Earth's human population served under its Caesar, it created a machine of malice with unparalleled technology. Towering 15 stories above Rome, this death machine was an engineering achievement without rival. Its architecture was constructed from 12 million pounds of concrete, but concealed beneath was a state-of-the-art elevator system. This deadly device is the iconographic Flavian Amphitheater, better known today as the Roman Colosseum.
The structure that we know as the Colosseum was only the grandest of many such features throughout the Roman Empire.
People think of it as an architectural marvel, but nobody really realizes that underneath there was so many mechanical devices going on, it was like its own machine.
The year 79 AD, 2 stories below the arena floor, the Colosseum houses a structure of catacomb-like corridors called the Hypogeum. Here in these dank, dark passageways, event workers create the special effects that surprise victims and Vestal virgins alike. There are 28 trapdoors hidden under the sand of the arena floor. From these portals, African lions and other large predators pop up into the amphitheater, and then blood begins to flow.
You have no idea where this animal is going to come from. You're in this huge arena, you're surrounded by thousands of people screaming for your death, and you just know that some big animal is going to pop up somewhere and you don't know where.
There is a theory that the Romans solved this problem by constructing a series of human-powered elevators. The original elevator system rotted away long ago, but now builders are constructing a replica elevator using modern materials to put this theory to the test.
This massive structure that I got behind me right now is our rendition of what it was like in the Roman Colosseum with the trap doors. The purpose of this elevator system would be to drop a trap door and unleash an animal, a tiger, a lion, onto the unsuspecting victims that were above.
Each trapdoor elevator requires the muscle of slaves. They walk in a circle as they push on the handles of a spindle crank. The flaxen line wraps around a pole as the spindle rotates. This applies tension on the remaining rope. As the rope is pulled taut, it travels through multiple sets of pulleys. The pulleys act as weight reducers and enable the men to quickly lift the cage and the hungry predator inside.
If you actually have a pulley at the top and a pulley in the middle, for every 1 foot that you pull the rope, the pulley is only going to go up 6 inches. So every time you add a pulley, you're actually going to divide that weight by the number of pulleys. If you had 30 pulleys, you divide the weight by 30.
When the cage reaches just below the floor of the arena, a second rope releases the lock holding up the trap door. The predator then climbs the ramp-like incline of the trap door and leaps out into the arena. With the predator now on stage, a second pulley system tensions the rope and quickly snaps the trap door shut, locking the animal in the arena, along with the condemned. To physically test whether a pulley weight reduction system can actually raise beasts to the floor of the Colosseum, a 480-pound lion will enter a steel cage. A professional animal handler will supervise the safety of the lion and everyone working around the machine. The combined weight of the lion and cage is 1,100 pounds. But with this pulley weight reduction system, the actual weight being lifted is only 400 pounds. The pulleys reduce 2/3 of the entire load. Over the centuries, countless thousands of animals fed the machinery of the Colosseum, but the sheer number of human casualties can only be estimated.
Although it's almost impossible to calculate exactly the kind of death toll over the 400 years of the Colosseum's history, estimates range at about 500,000.
This number makes the Colosseum one of history's most destructive death machines.
As an execution machine, the Colosseum was perfect. It just harnessed raw animal power.
But even after the ravages of time and earthquakes took their toll on the structure, the technology of the Colosseum has helped to advance civilization.
This is very similar to a modern elevator that people use on a daily basis.
Today, we have elevators operating on the same principles as the lifts in the hypogeum. Only now, when the doors open, it's unlikely an enraged beast will leap out. While advances in basic technology pushed many ancient societies forward, they were also used to punish and execute. The ancients mechanized fire, gravity, and force to create some of history's most malicious machines.
接下来回顾为一个当今世界主流信仰立基，并带领教徒得到救赎的重大历史事件——出埃及记大解密，探索黑死病、瘟疫与分海奇迹。圣经的秘密就在全新再发现，接着播出。